So now we have already completed the data ng cycle natin. So we can now compute yung load ng or mass flow rate ng ating evaporator. So evaporator at the low stage now. Now for the low stage, so we have the given load ng evaporator natin, which is the load ng previous ng product natin, which is already being computed. So we have the equation for your evaporator. So that would be the mass flow rate times the change in enthalpy from 0.1 to D, no? Enthalpy D. Okay? So substitute natin yan. We have 113. So that would be 0.16. So this is kilojoule per second, and this is equal now to the mass flow rate times the enthalpy 1, which is given, nakuha na natin, which is 1,450.7. And this is minus the value of enthalpy D. Okay, for the enthalpy D, we find that one. So that is 293, no? Enthalpy D. 293. 293.78. This is kilojoule per kilogram. So the transpose, so let's solve our mass flow rate. So I have a mass flow rate. So this is for my low stage. So let me put a subscript here, low stage. So this is 0.0978. So let's round this up to 98. This is now kilogram per second. Now, let's try to solve naman yung work ng compressor, which is yung part na ito, which is the low stage. So low stage, so usually at the low stage, so referring here from the figure, so that would be the change in enthalpy. So let's say multiply mo natin ng mass flow rate. Low stage, so times the change in enthalpy HB minus my H1. Okay. So for low stage, so substitute natin yung values ng mass flow rate. We have 0.0. That would be 98. So this is kilogram per second. Then the value ng enthalpy B, which is 16. So this one, 1605 minus my enthalpy 1, which is 1,450.7. So this is kilojoule per kilogram. So let's try to cancel yung units here. This one, okay. And we have now work at the low stage is equal to. Now I have the work which is equal now to 15.12. So this is kilojoule per second, or we can say this is now a kilowatt. Now, going back to the schematic diagram or yung ano natin, data series and also schematic diagram. So in order to solve the compressor's work, we have already the value AN2 prime. Now, what we don't have is the mass flow rate that is circulating on the high stage. Now, in order to do that, so we'll be using, we will isolate yung Cascade heat exchanger, and we will making an energy balance on this point in order na ma-solve natin ang mass flow rate ng high stage. Now, I have isolated now this one. So usually, papasok natin dito, let's draw lahat ng mga energy which is entering, no? So entering from the high stage, no? We have the high stage. So mass flow rate at the high stage and also the enthalpy. So anong enthalpy meron tayo dito? That would be enthalpy 4 prime, preparing from the figure. So this is enthalpy 4 prime. Now leaving the system, we have also the mass flow rate at the high stage times that would be ano yung leaving dyan? That will be enthalpy A. So we have the enthalpy A, no? Naman dito naman sa low stage, so we have again entering, that is mass flow rate at low stage. Tapos ang entering dyan, that will be the mass flow rate, the enthalpy, no? Enthalpy at point B. And leaving again, so the same also, we have the mass flow rate at the low stage. And referring to the figure diagram, we have is this one, we have enthalpy at point C. So meron naman tayong enthalpy at point C. Now, ito given, ito unknown, but this one enthalpy 4 prime, enthalpy A is already given. This one is given. Ito na solve na natin. And this one is meron na tayong value, and also this one. So, ang ano tayo dito, we have yung, let's make right here. Okay, so this is equal nga pala. Sorry. So, yung mass flow rate dito at saka mass flow rate dito are also equal. So, let's have an energy balance. So, I will write here energy in. So, lahat is equal to my energy out, which is leaving. So, let's sum up lahat ng energy entering the system, which is yung heat exchanger, and also summing up yung energy which is leaving the system. So, yung entering dyan, so mapapansin natin, this is mass flow rate, this one, yung mass flow rate at the high stage. So, times my, that would be my enthalpy 4 prime. No? Then plus entering mass flow rate, which is the low stage, times my enthalpy B, and this is equal to mass flow rate leaving, no, leaving the system. We have mass flow rate at the low stage, so ito, then multiply by enthalpy C plus leaving, we have also this one. So the mass flow rate at the high stage, so times my enthalpy A. No? Now, let's combine lahat ng may mass flow rate which is has coefficient na magpapare-pareho, no? Yung same. So, katulad nito, we have the mass flow rate. Let's try to combine lahat ng high stage. So, we have mass flow rate, the high stage times the enthalpy 4 prime. So, minus, lipat natin yon. So, that will be mass flow rate at the high stage times my enthalpy A, which is equal to the mass flow rate at the low stage times the enthalpy C. So minus kasi lilipat naman eh. So we have the mass flow rate uh, low stage times my enthalpy B. So factoring, which is yung common high stage, so that would be enthalpy 4 prime minus my enthalpy A, which is equal to the mass flow rate at the low stage times change in enthalpy, no? Yan. Okay? Since given na ito, and this one is also given, di ba? And we're trying to find out yung mass flow rate at the high stage. So we can rewrite our equation. So high stage, so that would be the mass flow rate at the low stage times the enthalpy C, enthalpy B, and this is all over, no? Divided by yung that would be so this is enthalpy 4 prime. So we have enthalpy 4 prime minus my enthalpy A. Okay? So let's substitute now the values para makuha natin yung mass flow rate at the high stage. So mass flow rate at the low stage, so kanina we have computed that one. So low stage, that is 0.098. So we have 0.098, so this is kilogram per second. Then multiply it by the value of enthalpy C. So for the enthalpy C, so referring here sa ating data na nakuha, so enthalpy C, that is 293.78. So let's try to substitute that one, 293.78. So minus yung enthalpy B naman, value ng enthalpy B, we have B, that is 1605. Is 1605. So this is kilojoule per kilogram. Now, all over, so this is all over, value ng enthalpy 4 prime, we have this one. So this is 361.19 minus enthalpy, value ng enthalpy A, that is 1476.365. So we have 1476, let me check that one, 76 0.365, so that will be kilojoule per kilogram. Now let's cancel, no? Cancel. So yung units dito, we have this one is common and this one is common, no? So finally, using your calculator, so let's find out what is the value of the mass flow rate at the high stage. That will be equal to 0.115. This is kilogram per second. So, meron na tayong mass flow rate na high stage. So, let's compute naman yung work. No? So, we have work of the compressor at the high stage. So, that will be the mass flow rate at the high stage. So, times, so referring to the figure, cycle diagram, so we have enthalpy 2 prime minus my enthalpy A. That would be enthalpy 2 prime minus my enthalpy A, no? Work on high stage, so we have substitute the value 0.115. So this is kilogram per second. Then times enthalpy 2 prime. So enthalpy 2 prime, that is equal to 1560. 1560 minus my enthalpy A, which is 1476.365. And this is kilojoule per kilogram. So, cancel ng units dito, which is yung common. We have your kilogram, no? And then, we have your work at the high stage is equal to, so I have a work of 9.66. So, this is kilojoule per second, or say this is kilowatt. So, let's combine all the work. So that will be the work total is equal to the work of the high stage plus work of my low stage. So total work, so for my high stage, so that is 9.66, that will be kilowatt plus low stage, so let me check that one. So low stage, that is 15.12, no? This is 15.12. So 15.12. So this is also in kilowatts. So total we have, so this is equal to 24.78 terms of kilowatt. Now let's convert this unit in terms of my horsepower. So we have, that will be 0.746 terms of kilowatt. So for my work total is equal to, so we have a work of around 33.22 horsepower. No? Now we have the work, the total work, which is 33.22 horsepower. Now let's try to compare doon sa simple before compression system. So ang nakuha natin from the previous, so that is it's around 30.58 horsepower. So this only indicate there is no savings of work, no? So by that is by means of overlapping yung temperature. So we will try na change yung system in such a way there will be non-overlapping. So when we say non-overlapping, kasi dito nito, if we will be basing this one, we are overlapping the temperature. Now, without overlapping, let's try that one. So that means that my, let's say, ang ano natin, ang evaporator 1 o yung high stage ng evaporator, let's say that's 20 degrees, and yung evaporator ng kabila o yung low stage, let's say that is 15 degrees. Now, subukan natin yung method na yun, no? So, ang high temperature, so i-adjust natin yung yung temperature ng isa ng evaporator natin without ng tinatawag natin overlapping. No? So, ibig sabihin na what we're going to do is I will change the evaporator temperature ng high stage. For example, this one, yung process. So, this is yung original no, na vapor compression system. Now, from here, I will cut the process. I will uh, change the process starting from here. So, if pag negative 20 yan, so ito yon. Okay? So, we have this one. So, itong part na ito. Let me try to adjust. Okay? So, yan. No? Then, ito yung aking magiging point 2. Point 1. So this is my, I'm gonna name this one as my, this 1 prime. So, gawin ko na lang itong, let's say this one is my 1 prime. Let's change this one para pareho doon sa kabila, which is letter A. No? So, isentropic compression, so we have, yan, ang kanyang 2 prime. No? Then, sa baba, so, sabi ko nga, we change it from 20 degrees. So, ito yung evaporator ng high stage. Then, for my low stage, so, it will be 15 degrees. No? So, we'll use a 15 degrees. So, somewhere here, ang 15 degrees. So, this is 20. Now, para doon sa 15 degrees Celsius natin, it is somewhere here below. No? So, let me try to write this one, yung 15 degrees Celsius natin, tabi dito, and that, extend doon. Okay? And let me try to erase this one, choose this one. Okay? Lipat natin to dito. Okay? So that will be my letter A. And dugtong natin ito. Dugtong. So we have this one. Okay. So, ito na yung magiging, so A, so this will be my point B, and this is my point C. So, pababa niyan, so that will be the intersection, dugtong nito, so that will be my point D, okay? And then, dugtong ulit dito ulit to complete the cycle. Yeah, no? So we have now this property, so that will be, okay, so lagyan pa na natin ito. We forgot here to put a 4 prime. Okay. So that will be the properties ng state natin kung saan lubrication process. No? So mapansin nyo, we have here a gap of pressure. So it is not overlapping compare doon sa kanina na kinompute natin, which is overlapping. So, that is yung sa high stage, ang evaporator niya is 20 degrees. Tapos, at the low stage, so yung condenser niya is on 15 degrees. But this time, ang meron tayo is that my high stage has a evaporator 20 degrees and my low stage condenser has a 15 degrees temperature. No? Now, using the table and the charts, so I'm able to get yung value ng mga enthalpies of the process. So, hindi ko na pinakita yung detail na ano. So, since lastly, kanina naman, so we have already demonstrated how to get the values of enthalpies. Now, we have here summarized all the values of the enthalpies of the low stage vapor compression cycle, and we have also the enthalpies for my high stage vapor compression cycle. No? Now, what the evaporator, we have your Q na evaporator, which is equal to the mass flow rate let's say that is a low stage times the change in enthalpy process, which is from here to here. So that will be enthalpy 1, minus my enthalpy D. Okay? And this is equal to 113. This is 0.16 kilojoule per second. We have the mass flow rate at the low stage, so multiply by the enthalpy 1, which is 1,450. So minus my enthalpy D, which is 269.9. So this is kilojoule per kilogram. So the mass flow rate at the low stage is equal to, this is equal to 0.095. So this is kilogram per second. For the work, we have the work for a compressor at the low stage, so that will be work at the low stage, so that will be the mass flow rate of the low stage times the change in enthalpy. Looking at the diagram, so the work of the compressor is from point 1 to point B, so that will be the change in enthalpy. So this is enthalpy B minus my enthalpy 1. Okay. So work from a low stage, so we have the mass flow rate 0.095, and this is kilogram per second multiplied by enthalpy B. So A, B, okay. So we don't have the value of enthalpy B. So let me check that one. So enthalpy B. So this is from the low stage cycle. So enthalpy 1. Okay, we forgot here. This is enthalpy B. Sorry about that one. So let me change this one. So this is my enthalpy B. Sorry. Okay, so that's been corrected now. So we have enthalpy B. This is that is 1575. This is 1575 minus the enthalpy 1, which is 114,000. So it is 1,450. So this is kilojoule per kilogram. So work at the low stage is equal to, so I have the value of 11. So this is 11.875. So this is kilojoule per second. This is watts. Now let's have again an energy balance in the system. So we have the mass flow rate, no? Mass flow rate of the high stage. So times the enthalpy 4 prime. So which is all lahat ng entering. So we have plus the mass flow rate of the low stage. So times the enthalpy point B, which is this is equal to the mass flow rate which is leaving high stage, so times enthalpy A, then plus the mass flow rate at the low stage, no? Then times with enthalpy C. So let's combine lahat ng mass flow rate dito. So we have ng which is yung which has a common na coefficient. We have mass flow rate at enthalpy 4 prime. So this will be minus. So minus mass flow rate of the high stage times we have enthalpy A. Okay, so sa kabila, that will be the mass flow rate of the low stage, so times my enthalpy C at point C, then mass flow rate at the low stage, so that will be times my enthalpy. Sorry, this is minus pala, no? So let me try to erase this one. This is minus. So minus low stage times my enthalpy B. Okay. So factoring, we have the mass flow rate at the high stage. So this is we have the change in enthalpy from 0.4 prime minus my enthalpy A. And this is equal to the mass flow rate at the low stage times enthalpy, enthalpy, so enthalpy C, no, minus my enthalpy B. So we have now the equation for to get the mass flow rate. So we have mass flow rate low stage times enthalpy C, enthalpy B, and so this is all over divided by the change in enthalpy 4 prime minus my enthalpy A. So mass flow rate at the high stage. So for the mass flow rate naman natin value, so we have for the low stage. So nakuha na natin yon. So that is equal to 0.095. So this is 0.095. This is kilogram per second. Then enthalpy C, we have enthalpy C which is 269.9. 269.9 minus my enthalpy B which is 1,575. This is 1,575. So this is kilojoule per kilogram. And this is all over divided by the enthalpy 4 prime. So that is equal to 361.1. So this is 361.1. So minus value ng enthalpy A, 1,480. 1,480. So this is 1,480. So this is now kilojoule per kilogram. And let's cancel the units here. This one, let me cancel this unit. So this one and this one. So for the mass flow rate, high stage is equal to is equal to 0.11, which is kilogram per second, or we can say 0.11 round off natin, that will be 0.1, so that will be kilogram per second. Now let's compute na, meron na tayong mass flow rate. Now pwede na natin computing yung mass, yung work ng compressor at the high stage. So this will be the mass flow rate of my high stage times, no? So let's check yung schematic diagram dito. So we have that will be value is enthalpy 2 prime minus the enthalpy A. So that will be enthalpy 2 prime minus my enthalpy A. So work at the high stage. So this is 0.11111 the kilogram per second. Then yung value ng enthalpy 2 prime, that is 1,537. This is 1,537 minus enthalpy A 1,480. So this is 1,480. So this is kilojoule per kilogram. So work for my high stage is equal. This is equal to 6.327. So this is kilojoule per second. Let's say this is already in kilowatts. Now, let's compute naman yung work total, no? Work total. So that is the work combined by the work by the low stage plus my of my high stage. So For my work at the low stage, so we have previously, uh, check that one. So we have that is 11.875. So this is 11.875. So this is already in kilowatts. Then plus my 6.327 kilowatts. So I have the value which is 18.202 terms of work in kilowatts. Now let's convert this one in terms of horsepower. So this is divided by 0.746 kilowatt. So my work total is equal to, so this is equal to 24.39 HP, or let's say it will be 24.4 horsepower. So that will be the work. Now, comparing yung kanina, compute natin previously, the work is, ang work total niya, that is ranging to 33.22 horsepower. So, makikita niyo yung savings of work when there is no overlapping of temperature, no, by means of energy balance. So, makikita natin we have savings of work comparing. If we will try to compare with overlapping temperature, pag may overlapping temperature, it shows just there is no savings of work. And if you will going to compare from the previous, so that is 30.58 horsepower. So if you use that temperature for your heat exchanger comparing to this one, so we may able have a savings work. No? So ganon yung if we have no overlapping temperatures doon sa pag sa heat exchanger ng Cascade system.